Hello everyone. In this video, let's discuss how to write a program to find the lowest common ancestor of a binary tree. Given a binary tree, find the lowest common ancestor LCA of two given nodes in the tree. According to the definition of LCA on Wikipedia, the lowest common ancestor is defined between two nodes P and Q as the lowest node in T that has both P and Q as descendants, where we allow a node to be a descendant of itself. So here they have given a binary tree 351620874. We need to find the lowest common ancestor of 511. For the node 511, the lowest common ancestor is 3. So the output is 3. So lowest common ancestor. So for 5 and 3, the common ancestor is 3 and that is the lowest common ancestor. And let's take another example. 351620874. So in this I need to find the lowest common ancestor for 5 and 4. So in this point of time, 5 is the lowest common ancestor. So the expression they have given us, the lowest common ancestor of 5 and 4 is 5. Since a node can be a descendant of itself according to the LCA definition. See, the node 5 can be a descendant of itself according to the definition which they have given here. Okay, so the root is having two nodes, 1 and 2. So 1 and 2, we have to find the lowest common ancestor. So 1 is itself a lowest common ancestor because 1 is the descendant of 2. Fine. Now let's try to discuss the logic in detail. So here they have given a binary tree. So this can be done with the help of a recursion. So let's define the method. So the method is public tree node. Here lowest common ancestor. So I'll give LCA for easy understanding. Here I have to pass 3 arguments. That is no root. Another one is two nodes. So here I am not going to give the node value. I am going to give the node address. So tree node P comma tree node Q. So here I have passed 3 arguments. So first I have to check my base condition. So in the base condition what I am going to do is, if root is equal to null, or root equal to P, or root equal to Q. If any one of the case. So whether we are reaching the null value or whether the root is equal to the P or the root is equal to Q, directly I have to return the root value. Directly return the root. Else I have to go for the left recursive call and the right recursive call. So tree node left, I am going to say only address. So tree node left is equal to LCA root dot left P comma Q. So P value and Q value should not be changed because we are going to find the LCA for P and Q. Similarly, I have to find the right recursive call. So tree node right is equal to LCA root dot right comma P comma Q. So I have called two recursive call. One is for left, another one is for right. Now I have to check the condition, which is left not equal to null and right not equal to null. If both are not equal to null, I have to return the root saying that that is the lowest common ancestor. So if left is not equal to null and right is also not equal to null, so at this point of time directly I can say root is the lowest common ancestor. If the condition is false, I will not go into this condition. Directly I can check one condition saying that if left is not equal to null, left is the answer, else right is the thing which I have to return. That's all. This is the logic of the program. Now I have to find the lowest common ancestor for 511. So let's trace the code. So here I am going to call the method LCA. I am going to pass root. What is the root value? The root value is 100. So 100 and pass. So now this is the address I am pointing. So root is pointing to the address called 100. Now I have to say root equal to null. No, root is not equal to null. Root equal to P. So P is having the address called 200. Let's define here so that we will not forget. And Q is having the address called 250. Okay. So root equal to P. No, root is to 100. Root equal to Q. No, root is 100. So condition becomes false. I'll go here. I'll be going with the left recursive call. So now I'm going to call the left side, that is 200. So I'm going to call the method LCA with the root value is 200. Fine. Check the condition. Root equal to null. No, root is not equal to null. Fine. Or root equal to P. Yes. Root value is also 200. P value is also 200. So which means we have got the node. So as of now, the root is the lowest common ancestor. So in this case, what I'll be doing is I'll be returning the root. So what is the root value? 200 will be returned to this place. 200 will be returned to this place. Which means for the left recursive call, for this recursive call LCA, what I am returning? Root value. Root value is 200. 200 has been returned here. So this function got over. Now from the method with the root 100, I have to call the right recursive call. So when you go to the right recursive call, I will be calling a node with the address 250. So here I will be calling LCA 250. So now what I have to do? I have to check the condition. Root equal to null? No. Root equal to P? No. Root equal to Q? Yes. Root is 250 and Q is also 250. So here condition is true. So right recursive call, this condition is true. Here I have to return the root. So in this function LCA of 250, I have to return the root. What is the root value? 250. So 250 will be returned to this place. Okay. So in this node, left recursive call is having 200, right recursive call is having 250. Both has been returned. Now check left to not equal to null. Yes, that is 200. Right not equal to null. Yes, that is 250. So I have to return the root value. So from this has been returned. So from the method LCA 100, I have to return the root value. What is my root value? 100. So 100 is having the node called 3. So 100 will be returned from this function. It will automatically take the value from the node. So 3 will be the output value. So this is the logic of the program. So we'll see one more logic where we'll have the descendant, where the node is itself a descendant. That will be the lowest common ancestor. That we'll discuss. Second example. So here I need to find the lowest common ancestor for 5 and 4. Okay. 5 is 200. For 4 is 800. Fine. Let's trace the code now. So first I have to pass LCA of root. So root is having the node called 100. So I'll be passing 100 first. So here LCA of 100. Okay, that has been called. Check root equal to null? No. Root equal to P? No. Root equal to Q? No. So none of the condition becomes true. I'll call the left recursive call where I'll be going to the node called 200. Okay. So now I'm going to call the method called LCA of 200. I've called. Now check root equal to null? No. Root equal to P? Yes. Root is equal to the node P. So in this case what I have written? I have written root. So the root is 200. 200 will be returned to this place. So here I'll be having the node called 200. So for this node 100, the left is having the value called 200 because that is the value which has been returned. Now from this node I have to return the right child. So what is my right child? 250. So I'll be going to call a method called LCA of 250. Okay. So when I call this, currently I'll be the node called 250. Okay. So now check root equal to null? No. Root equal to P? No. Root equal to Q? No. So what I have to do? I have to call the left child. So when I call the left child, now I'll be calling a method with LCA 350. Now currently I'll be on this particular node. So now check root equal to null? No. Root equal to P? No. Root equal to Q? No. So I'll be calling the left child. So here left child is null. I'll be calling null here. So when I call this, condition becomes false. So root value, so I will be calling LCA of null. So at this point of time, root equal to null, yes, root is equal to null. So this will be returning a value called null to the left child of the node 350. So for this particular method, I will be returning the value called null. So null will be returned here. Okay. Similarly, when I call the right child, that will also return the value called null. Okay. So left not equal to null, condition becomes false because left is having null, right not equal to null, condition becomes false. So I will be checking left not equal to null, left is equal to null. In this method LCA 350, left is null. So condition becomes false, I will be returning right value. My right value is null. So null will be returned to this place. So for the left child, the value null will be returned here. For the left child, null will be returned here. So from LCA 350, I will be returning a value called null to LCA of 250. That will be stored in the left. Now from LCA 250, I have to call the right child. Right child is 450. So LCA of 450. I will be calling the method called 450 here. So when I call LCA of 450, I will be calling the recursive call. Check root equal to null? No. Root equal to P? No. Root equal to Q? No. Condition becomes false. I will call the left child. My left child is having a value null. So that will return the value called null here. For the node LCA of 450, it will return null. For the node LCA of 450, right child also will be returning null. So here left not equal to null, condition becomes false. So I'll go here left not equal to null, condition becomes false. I have to return the null. So null is a value will be returned from the function called LCA of 450. That will be returned to the right child of LCA 250. So here null will be returned. Okay. After returning null, in this case left child over, right child over. For LCA of 250, left also over, right also over. So I'll be checking the condition. Left not equal to null, condition becomes false. Right not equal to null, condition becomes false. I'll go here, check left not equal to null. Actually left is equal to null, so condition becomes false. I'll be returning the right value. Right value is null, so null will be returned to. So from LC at 250, I'll be returning a value called null to the LC of 100 right child. So here null has been returned. After returning null, left child is having 200, right child is null. So check the condition, left not equal to null, yes left is not equal to null. Check right not equal to null, condition becomes false. So I'll go here, check left is not equal to null, yes left is not equal to null, which is 200. So I have to return the value called 200 from the function LCA, that will be returned to the main function. So LCA is returning the value called 200. So the node 200, whatever we are having, that is the lowest common ancestor. So 200 is the lowest common ancestor. So the output will be the value is 5, because on the node 200 the value is 5. So 5 will be the output value. So here I have to return the address alone, because their return type is tree node. 200 has been returned. That's all. Let's try to implement it as a program. So first I have to check the base value. So if root equal to null, or root equal to p, or root equal to q. If it satisfies any one of the conditions, I have to return the value called root. We have got the either of the case, either p or q, or the root is null. If the condition is not true, I have to call the recursive call for the left child. So tree node left is equal to recursive call, right? So lowest common ancestor root dot left comma p comma q. Tree node right is equal to lowest common ancestor root dot right p comma q. After this, I have to check the condition, which is if left is not equal to null and the right also not equal to null, directly I can return root. And right also not equal to null, which means we have got the lowest common ancestor, so return the root as a common ancestor. If the condition is not true, I have to check a case saying that left is not equal to null now. Left is the lowest common ancestor, or else right is the lowest common ancestor. This condition works when the node is itself at lowest common ancestor, which is for the second example. Since the node can be a descendant of itself according to the LCA definition. So this case works for second example. That's all. Let's run the code now. As it passes the test cases, let's submit the code. As it passes all the test cases. That's all.